everyone. So today we are going to take a look at the Atoms and Molecules unit, live step 5. So here is your library so far, and we're going to go to the Atoms and Molecules unit. We already completed the entire animation, so we're going to go down to the live video, and we're going to go to step 5. So in step 5, you have a slideshow presentation that you can go through, and along with that, you have 12 questions to submit. So hopefully within today's block period, you are able to submit all 12. All right, so let's go ahead and start our slideshow. So we're going to be focusing on the atom. So what exactly is matter made out of? So here we have a video that is going to zoom in on a piece of concrete all the way from what we can see all the way down to what the atoms look like under that special microscope that allows us to see atoms. So we are going to take this quick All right, so this is how we model the smallest particle of concrete. If we zoom into concrete all the way down 21 billion times better than we can see, we will be able to zoom in all the way until its smallest particle. And like we've said before, everything can be broken down into these particles. We call these particles atoms. So in the very center, there is our nucleus, and within the nucleus, we have protons and neutrons, and then spinning all around it in the outer part is our electrons. So if we exit out of this, you will be able to see it in motion. So there we have the proton and neutrons still staying in there in the center, and we have our electrons moving around all around the outer edge. But what exactly is an atom? An atom is the smallest particle of an element that can exist alone or in combination with something. Here are some examples of different atoms. Our first example is an atom of carbon. So in the center of carbon, we have protons and neutrons, and organized in the outer shells is the electrons. So a whole bunch of carbon put together makes graphite, which is what we use to write in pencils. Our second example is an atom of chlorine. Again, chlorine atom has protons and neutrons bundled together in the nucleus, and on the outer shells are electrons organized nice and neatly. Chlorine is used to kill off bacteria in pools. And our last example is an atom of oxygen. In the very center, again, there are protons and neutrons. The electrons are organized on the outer parts. And of course, we all know that we use oxygen to breathe. So let's think about it. How do we define an atom? What is an atom? Right now, I want you guys to pause and answer question 1. What is an atom? So now we're going to take a look at all of the different parts of an atom. So here we have a nice chart put together for us. And we're going to take a look at the protons first. The protons have a positive charge, and they are located in the nucleus. So right here, the very center, they're located in the nucleus, and they have a positive charge. The second part of an atom is the neutrons. Neutrons, they have no charge, so they're not positive, they're not negative, they're just right there in the middle. They are neutral, no charge at all. And they are also located in the nucleus. So they are bundled up with the protons in the very center of an atom. And the third and final part of an atom are the electrons. The electrons have a negative charge, and they are located in the outer shells, or called the orbitals. So they are located in the outsides. Now I want you guys to pause, and you are going to complete questions 2, 3, and 4. For question 2, you're going to complete the chart for each part of the atom. First, you're going to tell me where each part is located. And then you're going to tell me the charge of each part. Are they positive, negative, or neutral? For question 3, you're going to use the tool to label each part of the atom. You're going to label A, B, and C with either proton, neutron, or electron. For question 4, you're going to label the 3 parts of an atom once again. You're going to label part A, part B, and part C with either proton, neutron, or electron. Let's take a look back at our examples from earlier. We have a carbon atom, we have a chlorine atom, and we have an oxygen atom. So looking at all 3 of these examples, what are some similarities that you notice that they have all in common with each other? I want you to pause right now, and you are going to answer number 5. What similarities do you notice between the 3? Now we're going to take a look at what differences do you notice. So look at carbon, look at chlorine, and look at oxygen. What are some differences that you see across all 3 examples? I'm going to pause the video and answer number 6. What differences do you notice between the 3? Okay, so now again, taking a look at our 3 examples, can you tell, are all atoms identical? So identical means exactly the same. Can you say that all atoms look exactly the same? Pause the video and you're going to answer number 7. Are all atoms identical? Now we're going to take a look at the electrons in the orbitals. We're going to take a look closely at all of them. What do you notice about the positioning of each of these electrons? What do you notice about these? In carbon, chlorine, and oxygen. So now you're going to pause and answer question 8. What do you notice about the positioning of the electrons in each of these examples? So what makes a stable atom? If an atom has a complete outermost shell, it is stable. That means that it is not reactive and will not react with another substance. That means that no matter what, these atoms, if they come into contact with anything else, they will not react whatsoever. They're going to stay calm no matter what they're mixed with. So the rule is the rule of 8. So as long as the outermost shell has 8 electrons, the atom is completely stable. It is completely safe. So neon has 8 electrons in its outermost shell, and we're only counting the outermost shell. So 1, 2, 3, 4, 5, 6, 7, 8. And let's take a look at argon over here. Again, we're only counting the outermost shell. 1, 2, 3, 4, 5, 6, 7, 8. Both have 8 on the outermost shell, therefore both atoms are stable. As long as the atom has 8, the atom will be stable. With the exception, there are 2 exceptions, with the exception of hydrogen and helium. Hydrogen in helium's shell fits only a max of 2. So they only are able to use this inner shell. So they max out at 2, but all other atoms max out at 8. So, do all atoms behave the same way? Are all atoms completely stable? No. An atom will behave differently depending on the number of electrons in the outermost shell. So, the way an atom behaves completely depends on the number of electrons in the outermost shell. So here we have neon, 1, 2, 3, 4, 5, 6, 7, 8. Completely safe. Here we have argon, 1, 2, 3, 4, 5, 6, 7, 8. Because it's 8, we know that it is stable. But here we have sodium. We're only counting the outermost shell, so 1, nothing, so only 1. And here we have chlorine. 1, 2, 3, 4, 5, 6, 7. So sodium only has 1 on the outermost shell, and chlorine only has 7. So what does that mean? But before we take a look at that, I want you guys to pause and answer number 9. Do all atoms behave the same way? So let's take a look at an atom's reactivity. An atom is the most reactive when it has a near complete or near empty outermost shell. So remember, the outer shell fits 8. So near complete means that it's close to 8, and near empty means that it's close to 0. Okay, so whenever it's close to 8 or close to 0, that's when it's most reactive. So that's when there's big old explosions and all of that happening when it comes into contact with other substances. So we're going to take a look at sodium. Here is a sodium atom. On the very outer shell, we're only looking at the outer shell. There is only one electron. So sodium has one electron in its outermost shell. It needs to get rid of just one electron to have an empty outer shell. So that means that it is highly reactive. It is near empty. Near empty, meaning it's closer to zero. So that means it is very reactive. Let's take a look at fluorine. So fluorine on its outermost shell has 1, 2, 3, 4, 5, 6, 7. It only has 7 electrons in its outermost shell. It's only missing 1. So it's almost complete 8. It's barely missing 1. So it just needs 1 more electron to get a complete outer shell. So this makes it highly reactive. I want you guys to pause right now and answer question 10. When is an atom most reactive? Now we're going to take a look at when an atom is least reactive. An atom is not as reactive when it isn't as close to having a full or empty outer shell. So we're going to take a look at carbon. The carbon's outer shell has 1, 2, 3, 4. Carbon has 4 electrons in its outermost shell. It's not as close to having a full or empty outer shell, so it is not going to be as reactive. So if it needs to lose 4 electrons or gain 4 electrons in order to be complete, so it has a lot of more work to do, so it is not reactive. Taking a look at nitrogen. Nitrogen's outer shell has 1, 2, 3, 4, 5. Nitrogen has 5 electrons in its outermost shell. It's not as close to having a full or empty shell either, so it's not going to be reactive. It has 5 electrons, therefore it needs 3 more to be full, or it needs to lose 5 more. So that has a lot of work to do, so it is not going to be as reactive. I want you guys to pause right now and answer question 11. When is an atom not as reactive? Do you remember the reaction from the mystery substance videos? Did each of those substances behave the same way? Not at all, right? Substance A was a huge explosion, and substance B was not so thrilling. What does this tell us about the atoms that make up these mystery substances? What type of atom, how many electrons in the outer shell do you think it had to make this big of an explosion? And what number of electrons in substance B's outer shell had to not make an explosion? If the atoms in the substances are not the same, what specific difference could account for the different reactions? One of the substances might be made up of an atom that is very reactive, and the other might be made up of an atom that is not reactive. They must have a different number of electrons in the outer shell. So right now, I want you to pause and answer the last question of the day. Number 12, what evidence do we have that shows us atoms behave differently? And while you're answering that question, remember that the number of electrons in the outer shells determines how stable or how reactive it is. Let's take a look back at mystery substance A and mystery substance B. How many electrons do you think mystery substance A has? All right, that was pretty reactive. Now let's take a look at mystery substance B. How many electrons do you think mystery substance B has? All right, so that wasn't very reactive. Now it's time for the big reveal. Mystery substance A is pure potassium, a highly reactive soft silver metal, and it is reacting with water. Potassium is highly reactive because it only has one electron in its outer shell and therefore needs to lose one electron in order to have an empty shell. As for mystery substance B, it is pure silicone reacting with water. Silicone is not reactive in water because it has to gain or lose 4 electrons to have a full or empty shell. Make sure you submit all 12 of your questions, and once you do that, you are done for the day. Thank you all for watching, and have a wonderful day.